Today, we will be exploring the topic of the bacteria Clostridium botulinum and go into detail on how this bacteria and the potentially fatal illness that it causes is known as botulism.
This topic covers a lot of ground in terms of chemistry, that being the importance of the acidity of certain foods and how that plays a factor in the amount and quality of food storage and preparation that companies must take at the guidance of the government.
To begin, an explanation into what exactly the Clostridium botulinum bacteria is and how it can perpetuate itself in our everyday foods if we are not careful. We will be referring to the bacteria as CB from here on out for the sake of brevity.
The bacteria CB is a rod-shaped bacteria. They are anaerobic, meaning that they live and grow in low oxygen conditions.
The CB bacteria can be found in soil and marine sediments, most commonly in the form of spores that are not harmful on their own. But once they begin the process of growing out into active bacteria, they begin the production of neurotoxins. These neurotoxins have extremely negative effects on the human central nervous system, and it can destroy, paralyze, or adversely affect nerves or nerve tissue.
The spores in question are often found on the surfaces of fruits, vegetables, and seafood. An understanding of how the spores perpetuate into actual CB bacterium needs to be established.
For a brief explanation of what pH actually is, it is a measurement of acidity by the amount of hydrogen ions in something from a scale of 0 to 14, with 7 being neutral. Any pH that is below the value of 7 is considered acidic, and anything above 7 is considered basic. The lower the pH, the more acidic something is. Foods which have a pH greater than 4.6 are called low-acid foods. Microorganisms such as CB spores and bacteria are sensitive to a food's pH value. This is to say that a very low or high pH value within a food will prevent microbial growth. The issue arises in that very few foods have pH values low enough to completely inhibit the growth of microorganisms.
For the processing and packaging of almost all foods, a combination of microbial controls must be used to help in the preservation of food. These include heat processing, refrigeration, and drying. The most common is heat processing or canning.
When canning, some other compounds such as acetic acid are used to achieve stability. Acetic acid is also known as vinegar and is a familiar and effective source of food acid. In regards to low-acid foods, it is vital that they are properly acidified before they have a chance to spoil. Using that information, when low-acid foods are used in formulations, it is important that they are properly acidified before they can spoil. They must reach equilibrium pH within an adequate time.
In essence, food processing facilities would desire to get a pH to a level where they will not develop the CB bacterium. The magic number is a pH of 4.6 and below for foods with acidity. At this range of acidity, the toxins formed by the CB spores that develop into CB bacteria, then leading to botulism, are inhibited. Due to the spores being very heat resistant, temperatures of 240 degrees Fahrenheit or greater are commonly used, and process times may range from 20 minutes to several hours due to the resistance of the CB spores.
Properly stored foods are able to develop the CB bacterium that's developed from the CB spores, because most of the foods that already have CB spores present on their surfaces have little to no preservative ability. When the usual microbial control methods that food processors use are faulty and are done improperly, they serve not to help the foods involved in getting rid of CB spores. When these foods are then delivered and consumed, the spores have now developed as they are thriving in an environment with low oxygen, which is a result of improper canning. Oftentimes, a key sign that a food was improperly canned is a bulging can, the bulging being from the carbon dioxide the microbe produced as it grows. An example of a food-borne botulism that came from an unexpected source was the case of one 32-year-old woman who ended up getting botulism from one of the most unlikely sources, natural cheese that she had consumed from a gas station days prior. When admitted to the hospital, she denied eating any of the common foods that one can find CB bacterium present, such as exotic food, shellfish, raw meat, and raw fish, to name a few. All of this was likely a result of improper food handling in the production of the nacho cheese and its ingredients.
All in all, our government and many provisional agencies work to make sure that these guidelines are followed so that the food that we consume is safe to eat. Botulism is still rare to actually get, as safety in food preparation has been standardized for such a long time now that it is common practice among food packaging and processing firms. The level of understanding that these firms, the government, and scientists have made sure that botulism will never be a threat to the common consumer again. Unfortunately, due to the circumstances that entail this section of the project, no real experimentation could be done at home, so most of this presentation revolved around an exploration of the actual topic from the scholarly journals and papers that have been brought up so far, as a compilation of what CB is, and an explanation into a system that many don't think about when picking up their next groceries.
Safety of food is very important, and if we had the resources available to us to actually run an experiment with a handful of trials, here are some possible experimentations we would run down.
CB bacteria are incredibly hardy. They can survive harsh, acrid environmental conditions and thrive. Despite this, there are key conditions that make growth impossible even for CB. High acidity, lots of dissolved sugar, lots of oxygen, cold storage temperature, or low moisture. Pickles or canned cucumbers are incredibly popular choices for pickled food. A part of the reason for this is that they are sufficiently acidic to prevent CB growth. An experiment can be conducted comparing pickles, which is somewhat acidic, to green beans, which are not very acidic, in order to compare CB growth in improperly canned goods. Because boiling without pressure does not completely kill CB bacteria, one can compare 2 homemade cans of green beans that are boiled at regular pressure. To change their acidity, adding lemon juice or vinegar to 1 can of green beans can make it sufficiently acidic, and later comparing it to a non-altered can of green beans could be a possible method. Or alternatively, neutralizing 1 can of acidic pickles out of 2 cans with a base like milk of magnesia, ammonia, or baking soda can be used to see how pH changes CB growth. Another type of experimentation that can be done is with varying amounts of sugar. Comparing green beans that are improperly boiled with different sugar concentrations, one with added sugar versus no sugar added, to see how it affects CB growth is another route of further exploration. It would be essential to keep the storing temperature/environment the same, and the canning method, meaning boiling the can without pressure, to ensure that change in CB growth is due to the variables that are being tested. Testing pH before and after the cans are initially closed and open would be interesting to see if there is change, and CB growth can be measured by counting diluted colonies on petri dishes using a microscope.